Now we're going to start talking about expanding and collapsing numbers. Again, pulling our place values apart and putting them together. A number written as it's normally written, just as a number, is called standard form. A number that is written with the place values expanded out, like we're adding a whole bunch of numbers together, is our expanded form. We need to get those down. So starting in this video, we start off with the number 653,274. So what form is this number written? That would be standard form. That's the way we normally see a number written. And so how could you write this number in expanded notation? So think about that for a second, and then write the number in expanded notation. I'd like for you to do that horizontally, which is from left to right, and then I want you to write the number in expanded notation vertically, going up and down, like an addition problem. So pause the video, excuse me, for just a minute, and write this number in expanded notation both horizontally and vertically. Okay, so now that you're back, you should have written for left to right. Horizontal expanded notation should look, let me see if it'll fit right there. There we go. Like this. So we have our 600,000s, right? Our 5 or 50,000s, 3,000, 200s, 7 tens, and 4 ones. To write this in expanded notation vertically, it should look a little bit like that, okay? Same numbers going on up here. Remember, we just write how many we have in the place value and everything else is zeros to expand our place values. And then this is what we're doing for vertical. I like the vertical because it helps me kind of see the number and how it goes together a little bit better than the horizontal notation. So what patterns are you seeing in our expanded notation? A couple of things that I saw, and you could have seen some different things, but a couple of things that I saw, hold on, let me see if I can get out of that. Sorry. I can't grab that one. Let me move him out of the way so that I can get these, maybe. There we go. Okay, patterns that I saw were that the commas get lined up, a lot like decimals do when we're adding or subtracting decimal numbers. For whole numbers, the commas get lined up. And I also saw that the number of zeros decreased by 1 for each place when I went to the next place value. Something that you could add to a discussion, to the main discussion board, is other things, patterns that you see in the expanded notation. Do you need to write the addition sign after each number? No, you don't have to. Is there another way to write the addition sign? Yeah, we can just write the one addition sign, right? And we would get rid of all of these other ones right here and just have this one down at the bottom like a normal addition problem. Can you add the expanded notation of these numbers? Yes, we sure can. It's just gonna end up, and they call it collapsing the number because this top place value goes down to this one, and notice how it's just the 5 is just gonna move right on up into where that 0 is, and then the 3. So it's kind of being pushed down, and all the numbers will just fit together to get back to our original standard form of our number. That's why we call it collapsing. So yes, we can add the expanded notation. That should be expanded, sorry. And then can you predict what you might get when you add these numbers? Yes, we can. I can see that all these numbers are just going to fall right down on each other and go together and make our standard form of 653,254. Again, that's standard form, and this one are expanded form. How might writing the number vertically help you determine which number is largest? To me, By looking at the number of zeros, the place value of the digit is easier to determine in relation to the other digits in the number. So that's going to help me. Just seeing those zeros and being able to place them and count them is going to tell me which number's bigger. I can clearly see that 600,000 is definitely bigger than 50,000. And 50,000 is bigger than 3,000. So that really helps me see the difference in the values of numbers versus going horizontally like this. What word could you use to describe the opposite of the word expand? I would use collapse. Remember, we either expand it or we collapse it, kind of like an accordion. Okay. So we're going to do a little bit of practice with expanding and collapsing our numbers. We're not going to roll a die to make our numbers. I just went and kind of made some myself. So remember that a collapsed number is a number collapsed back into standard form. Collapsed number is expanded, collapsed to standard forms. So what role does the comma play in naming our large numbers? The comma is used to separate our groups of 3 digits as well as it separates our periods, right? Ends each period. Does the comma help in naming a large number? It does help in naming large numbers, and it does this by separating the large numbers into more manageable groupings. When we can just read 3 numbers at a time and then just put the name of that period after it, where that comma is, like the comma kind of names the period. It's just a lot easier to be able to read a number, such as number 1 would be 865,304,700,615. This one is 20,651. Then we have 865,292,417,006 is how we read those numbers. So you're going to go ahead and complete the rest of this paper on your own, following the directions. So here it says write each number that we created, or that I created, in expanded notation vertically. Remember, vertically is up and down. So you would write 8, and then every other little box is going to go to 0. And then you'll write plus. And then you'll put 6, and you're going to line it up in that second place value. And then the 1 goes to 0, 3 goes to 0, every other place value goes to 0. And then we add 1, and every other place value goes to 0. So you're just going to line those numbers up, one underneath the other one, for doing your expanded notation vertically. Then on the second page, you're going to write each number that you created in the place value chart in words. So that can get long, but y'all can do it. You've been doing it for quite a while. And then for the first number you created, that's where number 1 is, they're going to ask you which digit is in the hundreds place. So for number 1, the digit in the hundreds place is 6. There's an example. So you would write 6 here. 10,000s place, I'm going to find that one. 10, here's my thousands, there's 10,000s, and I would say 0. So there's a couple of examples for you. Sorry, I keep going the wrong direction there. So you're going to do that for the other 2 numbers that we created. And then down here you're going to use a comparison symbol. You're going to compare the first 2 numbers together. Remember, you draw your place value chart, you put your numbers in them, which we've already done from that first page, and then you start comparing the digits from left to right. And then you're going to order all 3 numbers that were created in that chart from least to greatest. Again, it's got to be in the place value chart, and you're comparing from left to right. When you're comparing more than 2 numbers, I would write 1, 2, 3, 4, 5, 6 to the left of your place value chart when you determine which ones are least and which ones are greatest. Okay, you're on your own on that one, and then you need to complete the other assignments within this activity and submit them using the assignment tool. Remember, the assignment tool is the hand with the piece of paper. Alrighty, don't forget you can always email or chat or call me if you have any questions or any other issues.